Okay, we're back already? Alright, let's see how you did. So, going through what Jason showed the other day, how to figure out your wind correction angle and your ground speed. Okay, we're going to start out by putting the wind direction underneath the true index on our E6-B. So if you look up here, there's the true index. Alright, we're going to take and swing this over to 330 degrees right there. Okay, then we're going to take and slide our whole thing down until the grommet is on 100 knots. Okay, that just makes it easier so we don't have to do math. Then we're going to take and go up from there the number of knots for your wind speed. Wind speed was 16 knots, so we're going to go up. There's 5, there's 10, here's 15, and right above that is 16. I'm going to make a mark. Now I'm using a pencil, alright, which is just fine. Jason used a dry erase marker the other day. That works great too. You don't want to use a permanent marker. Don't want to use an ink pen because that will tear up this little plastic sheeting here, and you don't want to keep burning through your E6Bs. Now, next thing though is to swing this around and put your true course underneath your true index. So our true course was 175 degrees. So I'm going to go ahead and swing this around just like so. There's south 175 degrees right there. Okay. Then I'm going to slide until our wind mark right here is over our true airspeed, which I said was 105 knots. Okay. So I'm going to slide it up, slide it up, slide it up, and there's 105 knots. Oh, a little too far. Bring it back down, 105 knots right there. I can get it to stay right on the spot. So now if we look at, there's 175 as our true course. Alright, now if we look at where this wind mark is located, we see that it is 1, 2, 3, 3.5 degrees or so. So we'll just go ahead and say 3 degrees right of our center line. Okay, so our wind correction angle is +3. Alright, because we add a right wind correction angle. Now if we look to find out what our ground speed is, since we put our wind mark on our true airspeed, alright, we look where the grommet is located, and that's right above the 120 mark. So our ground speed is 120 knots. So let's go ahead and plug those numbers into our formula and see where we are now. Okay, so we're back here to our original formula. True course minus left plus our right wind correction angle equals our true heading, minus an east plus the west variation equals our magnetic heading, minus an east plus the west deviation equals our compass heading. Okay, said winds were 330 at 16 knots, true airspeed was 105 knots. Okay, so through that information we found out that our wind correction angle is +3 degrees. Since it was 3 degrees to the right, you add a right wind correction angle. So now our formula looks like this. Okay, we found out that our true course earlier, looking at using the plotter on our chart, was 175 degrees. We're adding the 3 degrees for our wind correction angle, and that equals 178 degrees is our true heading. We still have to figure out what to do about this variation. Okay, now I told you earlier we'd get back to how to figure out the variation, so it is time to go ahead and do that now. So every so often on your chart, you'll see these magenta segmented lines running vertically up and down the chart. Okay, these things right here. These are your magnetic variation lines. It shows you what the magnetic variation is in that area. So you look for the one that's closest to the airport where you're flying out of. So there's Spinks. Here's another one of these right over here. Okay, if you go down and look, all right, it's kind of blurry on here. I'm sorry, the focus is a little bit off. But it does say it is 5 degrees and 30 minutes east. Okay, so 5.5 degrees east is our magnetic variation in this area right along our route of flight. So we'll go ahead and use that. So here we are back at our formula, and we found out just from looking at the chart that our variation is 5 degrees 30 minutes east, which is right around 6 degrees. When it comes to flying, it's very tough to keep on a ½ degree accuracy on your heading. You know, even 1 degree or 2 degrees is tough for a lot of people. So it's really no harm to round your ½ degrees to the nearest degree just to make things easier. So you can round up or round down. I typically will round up to the next nearest degree, just, my own personal preference. Okay. So we're going to go ahead and use 6 degrees east as our variation. So if we plug that in the formula, we see now that our true course is 175 degrees. Adding 3 degrees for our wind correction angle gives us 178. Now we're subtracting 6 degrees because we subtract the eastern variation, minus an east variation, so we're subtracting 6 degrees. And that gives us a magnetic heading of 172 degrees. Okay. Now to convert this magnetic heading into our compass heading, we still need to use this deviation. Deviation is defined as the errors in your magnetic compass in your airplane. Now, why would your airplane have errors in the magnetic compass? Well, because you have a big block of iron in the form of your engine within a few feet of your magnetic compass. Iron is a ferrous or magnetic material, so therefore it can cause some errors. So each airplane will have a card in there called the deviation card right near the compass, a lot of times right below it, indicating on each heading, each major point on the compass, what the deviation is at that point. So what you would do is say, okay, for the 172 degrees, which is, the closest one in your magnetic card would be 180 degrees. So looking at 180 degrees, what is your east or west deviation on your airplane? And that gives you your compass heading. Okay. So you'll want to either take a snapshot of it with a digital camera, your cell phone, your iPhone, whatever. You also might want to take and just copy the information down in a notebook, or some other way make a copy of that deviation card. That way, when you do your flight planning for your check ride or for your cross-country flights, you can actually account for that and have your actual compass heading on your flight plan. Okay. Most of the time, though, the magnetic heading will suffice for your planning purposes and get you where you want to go. Well, I hope you enjoyed this little demonstration I did for you today. If you'd like to see more, please let me know in the comments, and I'll see if I can help Jason to contribute more in the future. If you have any questions or comments, please leave a comment here on this blog post, and I'll be glad to reply to those as they come in. Otherwise, you can reach me on Twitter at Toronado. That's the O's are zeros in Toronado, so it's T0R0NAD0 on Twitter. Or you can reach me via email at gustafson.pj@gmail.com. Thank you very much for viewing this video. Thank you for supporting Jason Shepard and M0A.com. And when it comes to flying, keep the shiny side up, dirty side down, and the pointy head forward. Have a great day.